In this video, we're going to be looking at limits 2 as x approaches infinity. Right, perfect. So remember, firstly, you always try to substitute and see if it works, right? So here, if I were to substitute infinity here and here, the answer will get bigger and bigger. So here I'll get infinity basically. So I'm getting infinity. Then if I were to take this infinity and get it there, I'll get minus infinity, right? So this we call it indeterminate form of infinity minus infinity. So we cannot substitute infinity yet. We need to simplify this first. Okay. So here, ladies and gents, I'm going to use this. I'm going to convert this to a root. Remember, we have a to the power n over m can be written as m root of a to the power n. So basically, if you have a fraction exponent, the denominator, it's your root. So we all agree that with that, we can write this equation as the cube root because the bottom is 3 there. So the denominator is 3, which is your root. So you have cube root of that plus that. So this will be to the power 1. So I'm not going to put a bracket because to the power 1 is just not shown, right? But if it was to the power 2, let's say here, or any number, I'll still put this to that bracket, right? Then I have minus x. Right. Perfect. Remember, this form and this form is still the same. Is the indeterminate form of infinity minus infinity. Sharp. So I need to simplify this. So ladies and gents, here I'm going to do this. I'm going to use the fact that I can rationalize the numerator. So if I have a root, I'm always going to try to rationalize. If it's at the bottom, I rationalize the denominator. If it's at the top, I rationalize the denominator. So in this case, let's see. This is a cube, right? Let's agree, if I have x squared minus or plus b squared, I mean minus b squared, I can use difference of two squares to say a minus b, and then a plus b, right? Sharp. This, you use this information if you have what? If you have square roots, you do difference of two squares. But let's say we have cubes. Plus a cubed plus b cubed. Do you agree that this can be factorized to, remember, this breaks to a times a times a is a cubed. The b cubed breaks to b. So the first bracket, just take this. So you have a, and then that, you have b. You take the sign there. And then the second bracket is easy. A times a times a gives you a squared. B times b gives you b squared. Then a times b gives you ab. So the first one, you times it by itself, gives you that one. This times that gives you that one. This times that gives you the million. Which means we're going to have, if it's a plus here, this will be a minus. Then that will be a plus always. And then if this was a minus, that will be a minus. Then that will be a plus. Ne? So that is the difference. So if you have, if this one, you're going to use it if you have cube roots. This one, you use it if you have square roots. Okay, perfect. Now let's go back and see there how we're going to rationalize this. Okay, so because I have a cube root, I have to use cubes. Here's like, I'm going to call this guy my a, and then I have minus my b, right? So x is my b. Here I'm going to have a squared. Remember, in the middle is this times that, it's ab. Here it's b squared, right? And then if this is a minus, this must be a plus. The last one, it's always a plus. So to rationalize, I have to multiply by this part because I already have this part, which is there. So this part here is my A, that part is my B. Think of it that way. Ne? So we have limit as x approaches infinity of cube root of x cubed plus x squared minus x. Then we close that, we open a new bracket. Now I need to do a squared. This is my a, I'm going to square this, ne? Which is cube root of x cubed plus x squared. And then I'm going to square this because this is my a squared. And then if this is a minus, we're going to have a plus here. Then this times that, we do a times b, which is x. And then you have cube root of x cubed plus x squared. I'm sure you are following, ladies and gents. And then this is going to give us this times that, which is plus x squared. Right. And then so that we don't change the meaning of this equation, we need to divide by the same thing, so that it's like we're multiplying by 1, right? So you have that. Sorry, we have this, and then we have that. Let me just rewrite this quickly. Plus x cube root x cubed plus x squared plus x squared. Right, if you were to cancel here, they will cancel each other. So we just multiply our original expression by 1. So we're not changing the meaning of the equation. Okay, so let's proceed. We're going to have equals to. Now, ladies and gents, remember the top now is basically a cubed minus b cubed, right? Remember the middles are going to cancel from cubes, right? Sharp. So basically here I'm gonna have x cubed plus x squared, because I'm going to have this one cubed. So this cube will cancel with the cube that I'm going to put. Okay, let me show you. Remember, a cubed is basically this cubed. So this 3 will cancel that. So you're left with the inside basically. Then you're going to minus by x. Remember I said our b is x. So we have x cubed here. So minus x cubed. That is our top, we're done. And then the bottom. On the bottom, you have a cube root of x cubed plus x squared. That square can come inside, right? Plus x, and then you have a cube root of x cubed plus, oh, there's a cube root there, yes. Cube root of x cubed, x squared plus x squared, right? Awesome. Now let's keep on going. This will give us, let's see, this will cancel. That's why at the top you're left with x squared. And then at the bottom, let's see, you have cube root of, so ladies and gents, here I'm going to make 2 brackets because of the square. So it's x cubed plus x squared. And then you have another x cubed plus x squared. This will simply, if you were to FOIL like this and then like that, you'll end up having x to the power 6 plus 2x to the power 5 plus x to the power 4. And then plus x cube root of x cubed plus x squared plus, let's see, plus x squared there. Sharp. So now, guys, here I'm going to divide every term on top by this, by x squared. Ne? So I'm dividing both sides by x squared. And then I'm also dividing the bottom by x squared. So the reason why I'm dividing, I always divide by the highest power of the top. Ne? Sharp. So let's see. At the top, it's x squared divided by x squared. I'm left with 1 all over. Let's see now. Here, guys, if remember, I'm dividing by x squared. So I'm going to have, okay, over x squared. Remember, I'm dividing, so it's 1 over x squared here. Then here it's x squared. Here it's x squared. Right? So now let's see. We are now going to have this. We are going to have, I'll show you something now. I'm going to have cube root of, right? If I need to take this back inside, I need to multiply it by to the power of 3. So it's going to be basically, if it's inside, it's going to be 1 over x to the power 6. Because 1 to the power 3 is 1, x squared to the power 3 is x to the power 6. So it's like I'm multiplying by this inside. No? So x to the power 6 plus 2, x to the power 5 plus x to the power 4. Right. And then plus, if we check here, ladies and gents, x over x squared, it's 1 over x, right? And then I need to take this back inside. I need to take it back inside the cube root. So I'm going to multiply this by that. So it's 1 over x cubed when it's inside. It's 1 over x when it's outside. It's 1 over x cubed when it's inside. So I need to take it inside. So I multiply by that. And then I have x cubed plus x squared. And then need to close this. And then plus 1 there, right? Awesome. Now let's see what does this simplify to. Oh, guys, I forgot my limit here. I've been forgetting my limit. Sorry about that. Remember, we always need to keep our limit. So this is equals to limit as x approaches infinity. Don't forget that. I'm sorry about that. This is the same as limit as x approaches infinity. Let's keep on going, which is the same as limit as x approaches infinity. Right. Now let's keep on going. Let's keep on going. So now I have limit as x approaches infinity. Right. We have 1 over, let's see what does this simplify to. This times that, I can see that everything is over 1. Even that's over 1, right? So here I'm going to have just 1, right? And then here I'm going to have plus 2 over x, because x to the 5 will minus here, because since this is at the top, this is at the bottom. So I'm going to be left with x to the power 1 at the bottom, plus 1 over x squared, right? Plus cube root of this will cancel with that, so we're left with 1 plus 1 over x, because this 2 will minus there, so you're left with x at the bottom, then plus 1. Right. Now that we have simplified that, we can easily say, okay, now I can say, okay, this part, let me circle all the parts that have an x basically. This part, and that part are approaching 0, because as the bottom gets bigger, and bigger, it means the whole entire fraction is getting smaller and smaller and smaller, because we're dividing with a bigger number. So basically, we are left with You no longer show the limit because we have substituted now, but you don't have to show the substitutions. Eh? So you're going to be left with cube root of 1 for this part, plus cube root of 1 plus 1, which is 1 over cube root of 1 is 1, cube root of 1 is 1, plus 1, which is 1 over 3. And that is what this limit simplifies to. Thank you very much, ladies and gentlemen. Aluta continua. Tango.